So welcome to the next video. If you watched me just coming from that video where I made this low poly tree model, in this video I'm going to be bringing this one into Unity and show you a little bit about how I implement it in the game and some of the shader effects that I throw on them. So let's start here. Let's just grab this tree, the most recent one that we made, the latest version here. And a few things I want to run through. And the first one is that I like to keep the scale at 1, making sure that the object scale is 1. If it isn't, you can press Control A and apply rotation and scale to make sure that it's object scale 1 here. That's always nice to work with. And I see now that this is quite a large tree that I ended up making compared to the other trees, but that doesn't matter. We can scale that in Unity later on. So another thing I want to do is Unity unfortunately works in a different the up and down axis is different in Unity and Blender. Blender uses the Z axis as up and down, and Unity uses the Y axis, and that creates a whole heap of annoyances and problems. So when you import it, Unity actually applies a rotation, but I always like to have the object in the proper without any rotations. You know, I want up to be up at all times. That probably doesn't make any sense, but if you've encountered that problem, you know what I mean. And I've got a script here called in Unity Tools called Simple Rotation Fix, and I hope I can find the link to this because I downloaded it off the internet a long time ago. So look in the description below, and hopefully, if I find the link to that one, I'm going to be Googling it. I'll put a link in the description to that one. And basically, if you have this object selected, all you need to do is click on Simple Rotation Fix. And that fixes the rotation. Basically, you can see now here that it's got a rotation of 90 around the x-axis, and that's by, but then it rotates the object back, so it looks the same in Blender, but the actual transform has a rotation on it now. And it still looks the same here, but thanks to this little rotation now, when we import it in Unity, it'll have flipped it, so the the Y and Z axis are correct. So now if I go to File and Export, I can export this as an Fbx file. I like to work in Fbx. And especially if you're making assets, you have to make it in the Fbx or some other formats, but you can't make it in the blend format. It doesn't allow, or at least it didn't used to allow to keep it in the blend format. So let's call this one, let's see, let's name it Tree 013 Twisty, I believe we called it. And then this is important. I would just want to export this particular selected object here. And then here, as you can see, the up axis is set to Y axis, which is how Unity uses it as well. And then we export it. Remember, selected object only. And now we have this one here. So it's time to bring it into Unity. And if I load this one up here, I've got Unity running. Here are some of the other trees that I made. Hopefully this new tree will look decent and not too many polygons. So let's hide these that I had before. There's one more somewhere. There we go. And let's import this tree by dragging it into here. And then another thing that you'll notice is a scale problem when you import it. If I pull this in the scene now, you can see that it looks properly sized in the scene here, but there is an issue that I don't like, and that is, so the size is the way I want it to be, but here, see, scale is set to 100, and that sucks. You don't want to have, I want it to be scale 1. To fix that, I do this. If you know of a better trick, let me know. I don't know one, so basically I just untick this, use file scale, and apply it, and as you can see now it disappeared. But if I go back now and reset the scale to 1 here, then everything is the way I want it to be, and the rotation is 0, 0, 0, which is also what I wanted to do, and that's thanks to this little this rotation fix that rotates around the x-axis by 90 degrees. That's thanks to that we have a scale 1 and rotation 0 here. So here we go. And then what I've done is I've created a material here called Lowpoly Tree Wind, and that's got 2 textures. So you'll recognize this texture from within blender, which is just the 3 green colors and a tree trunk color. And I also added another texture called autumn texture, and that's got the same layout with 3 different shades, but here with autumn leaves instead. I'll take you through this shader as well, but basically if I apply this one now to this tree, you can see that it looks like this. And it's actually got some snow on it now, as you can see, and that's because I've got in this shader that I've made in Amplify here. This is a great tool to actually make shaders in. I used to code my own shaders for my procedural planets axis, for example, and it takes forever to code and troubleshoot. But using Amplify, or Unity's used to have the shader graph, and now it's implementing its new shader. So is it the new one that's called shader graph, maybe? But that's still in preview, I think. So I ended up buying this Amplify, and I'm having a lot of fun with it. It's really intuitive and really powerful. So I advise you to get this one if you want to start getting into shaders. Like this one took me maybe 15 minutes to half an hour to get sorted out. But if you're new to shaders altogether, it'll probably take a lot more trial and error. But that's the good thing about this. You don't have to code it. You can look at tutorials and then start playing around with texture sampling and then figure out what you want to do with it. So basically what I ended up doing here is this shader. I've created this snow slider. So if I drag this one down to 0, as you can see, there's no snow on it. Whereas I drag it up, it starts adding snow on any faces that are facing with a normal that's pointing upwards. If I gradually go down. So basically, let's put it into play mode as well, actually. So I get the animation at all times. And there we go. There you got the waterfall going as well there. And the guy with the flag. I just have to do this now just because of that. Let's go here. Check this out. You go into the car. This guy is a hero. Check this guy out. He'll get up all the time. Every time. That's another cool thing. Never mind. That's not what I was meant to do. Back to the tree. Let's disable that flag guy because he's standing there with the... Oh no, he can be there. So that was the snow shader effect. So if you want to snow cap all the trees, as you can see, it even snow caps this anything that's facing upwards on the faces of the tree trunk. It'll throw shades on some snow onto that as well. The other slide that I put here is this autumn slider, and that crossfades from this green texture into the autumn colors. So if we disable the snow, then you have an autumn tree here instead. And maybe you want to have a transition between the different seasons, so you can have that. And the final thing that shader does as well, you can see that it sways a little bit in the wind. And I've got a few settings for that. The bend amount, if you want it to look really unrealistic, you can do that. And that looks stupid, so let's bring it back down. And the other thing is a frequency in the world. You probably wouldn't want to have that one too high either, because that looks a bit strange as well. But basically that's to get variations between the trees. So they're not all waving at the same time. And then you can set the wind direction. So, and you can do a lot more fancy stuff in the shader if you want to, and have it sort of it shaking up and down and rippling in different effects. But for my purposes, I'm going to be keeping this at a really subtle effect like this. So I think I'm going to keep this shader quite simple like that. Let's bring the green tree back again here. And then if I duplicate this tree as well, you can see this effect a little bit more. Let's see, there's the twisted tree. Shift, oh no, in Blender it's Shift-D, but in Unity it's Control-D to duplicate. And then R to rotate. And R, sorry, it's E to rotate, and then R to scale. Then Shift-D to do. Let's see, Control-D to duplicate. Let's move this one to there. And E to rotate around the up axis there, and then let's press R to scale it down a little bit. And then I'll just make some more bunches here. One more copy, Control D, W to move it, and let's put one here, E to rotate, like that. So, and then as you can see now, if I select this shader again, if I modify this, it'll snowcap all the trees, and that's because they're all sharing the same material. And a lot of the time you probably want to snowcap all the trees or make them autumn color. But if you wanted to have different shades of green on trees, then you need to duplicate this and make multiple textures of it and have that one. Yeah, and where did my car go? Did it go underwater? Yeah, it did. Okay, so I guess I should mention a little bit about this shader as well. I won't have enough time probably in this video to do like a full shader walkthrough, but I'll talk you through a few of the things just to get the general idea of it. And so these are the two texture samplings that I do. So it looks at the UV and it picks, as I laid it out in Blender, it takes the tree trunk color from here and the foliage colors from here. And then this is a lerp function, so linear interpolation, and it takes it from the summer colors to the autumn colors. And then I use this autumn value, which is a property that you can see that I showed you here. This autumn property here. And when I pull this one here, as you can see, this slider is changing, and it basically sets the value of this interpolation, the linear interpolation. So when it's at 0, it samples everything from this texture and sends it on. Whereas if I slide it all the way to over here, it takes everything from this texture and outputs it here. And then, so that's just to get between the summer and the autumn color. And then we wanted to add the snow coverage as well. And I do that by having this, so whatever, let's see. As you can see here the output from this. When I have the slider here, it sends the green texture through, and as I pull this one, it changes it into this one. So here, I want to have the snow color. So I want it crossfade from whatever color the tree is at the moment to white. So that's the purpose of this one. I want to crossfade in some places. I want to crossfade it to white, which is the snow color. And to say what I'm gonna, this one actually changes the whole texture, as you can see. If I go here on the snow texture, wrong one, here, you can see that it just, all this one does is it takes whatever the output from here is, and it crossfades it based on this slider, the snow slider, to white. And I do some tricks here to get the snow to, and I had to do some tricks, let's see, to get this alpha value. Basically it remaps this one, which is a slider from 0 to 1, and it remaps this one to 0, or the first half from 0 to 0.5, it remaps it to 0 to 1. And that's because I wanted to crossfade this one only between, as you can see, it's, let's have a look, not there, here. So it reaches full white. When I reach 0.5 here, it's all reached all the way to full white here. And that's how I wanted it to do. I wanted it to remain white all the way from 0.5 here to the top. So that's why I have to do that one. And then I also need to use, here's probably maybe the more difficult thing to wrap your head around, especially if you're new to this. But as I showed here, I only wanted to colorize the faces that are upwards. I don't want to colorize these because snow usually lands on top and then it stays on top. It wouldn't really snow from underneath. So I want to find a way to get the shader to know that I only want to apply this white color to anything that's facing upwards, all the faces that are facing upwards. And by doing that, as you can see here, it gradually adds, so at the low spectrum here, it starts to colorize faces that are truly facing up, like nearly, the normal is pointing nearly straight up. And then as I go with the slider here, it'll start picking faces that are a little bit more on a tilt. It's not directly upwards. And the further I get to 1 here, it'll start adding faces that are nearly facing sideways as well, but they're all still have got some sort of a bearing to the up direction there. And this is what I came up with to solve that problem. I used, we can walk through that one actually. So I've got this snow here, which is this value that goes from 0 to 1. First I wanted to subtract 0.5. So this one, whatever this one is, it's going to be subtracted by 0.5. And that's basically because I don't want to have this effect at all on anything when the slide, this is going to sound stupid, but I don't want this to have any effect at all when the slider is between 0 and 0.5. So that's why I take away 0.5. So when this one is at 0, it's actually minus 0.5 here now. And that's, I want it to be that way, but I do clamp it here to 0 to 1. So when this slider is between 0 and 0.5, it's actually clamped to 0 at all times, because I don't want this to have any effect yet, because I was crossfading on the first half of the slider, and it's not until I reach 0.5 here that I want to start altering the effect on how vertical the faces need to be. So that's why I take away 0.5 and I clamp it to 0 to 1, and then I remap it. So I know that the value now is going to be between 0 and 0.5 here, and I want to remap that one so it's between 0 and 1 here. Apologies if this doesn't make any sense. It takes a lot of trial and error and getting your head wrapped around to what you want to achieve with the sliders and how they should behave. And this is how I had to do it to get to this to look the way I wanted it to. So finally here, after this remap, I also do another remap. So between 0 and 1, I wanted to increase and invert it. So whenever it's 0, the output from this one will be actually 100. And then when it reaches 1, this one, I wanted it to throw out the value of 1. And finally, I feed this value into this exponential, the exponent in this power math operator. And that brings me, so that's just basically to get a value. All this does is just to transform a value of the snow slider into a value that I need, an exponential value, to say, and I need that one to describe here, to get the math properly, to say that I want to gradually increase it from a vertical one to a horizontal face here. And to tie this together then, here I'm looking at the vertex normal, and the vertex normal is whatever is perpendicular to the face itself. So the normal of this face here that you can see here, for example, points nearly straight up. So this is a vector 3, and I take the y component from that vector, which is the y-axis, which is the up and down axis. So I take the y value of that one. And if this is a face that's pointing straight up, the y value will be nearly 1. And if this face here, for example, which is facing nearly to the side, then the y value of that one would be nearly 0, because it doesn't have any component that points upwards. So I multiply that by the object scale as well, because I want this effect to be the same as well, whether I'm scaling the object or not. So I had to multiply the normal with the scale of the object. And then I also do max here, because I didn't want this to apply to the underneath of the object. So I do a max value of 0 and the value itself. So any negative value will result in 0. And any value that's greater than 0 will be passed through here. And finally, so I take this y component of the normal, and I use this value that I transformed from the slider into an exponential value here. And that's finally that's what's needed to get this effect so when I pull the slider again, let's select this material. As I pull the slider between 0.5 and 1, it transforms this value then and gradually picks this y component and then uses the exponent up here to gradually increase the snow coverage, and it'll hit closer and closer to the reason why you need it to be the power and have such a big exponential value is because for a face here that's nearly sideways facing, this value is going to be very, very low. So I need to transform this snow value, which is at 1 here. I need to transfer that into a really big exponent. So if this value is 0.05, for example, by raising it to the power of a really big exponent, that 0.05, for example, will be nearly 1, which is needed to get the snow fully white on this side here. So that explains some of the logic between the snow and the autumn colors. And finally, I also have, this is what I've got to get the swaying animation going. I use the world position. So the vertex world position. And then I add X and Y, or X and Z, which is anything but the up and down axis, basically. I just add those together to get some value. And the only reason why I do that is because I want the trees to move a little bit independently or differently from one another. So I just use the world position to as a reference for that. And then I multiply that one with the world frequency value here. And then I add a time value to that one, so a time parameter. And this is a time value in the shader that keeps increasing all the time. And then I use the cosinus of this value. So that's just that every vertex in the scene, depending on where the trees is, will have an incremental value, which is different from anything that's next to it or near it. And then I get the cosinus of that value to get the swaying back and forth. And once I have that value, the cosinus, which is going to be between, it's going to be quite a low and persistently low value. So it's not going to run away into the like a big number. So I take the vertex position then of a vertex here, for example, and I multiply that one by this cosinus value. And that's when you start getting the vertex position and the cosinus in relation to where it is in the world will make it sway then back and forth a little bit. And then I use also some different parameters. I multiply it by the bend amount. So if I reduce the bend amount here, it'll only be a slight, whereas if I increase it to 1, it'll look really stupid and unnatural. So that's why you don't want to keep it at 1, but you want to keep it down here somewhere. So I multiply it by the bend amount, so you have some flexibility in the configuration there. And then for some reason, I have to recall why I'm doing this now. I add the X and the Z value together. And why do I do that? So I have the swaying value. I multiply it by the bend amount. Oh yeah, it's just to get, again, so they don't move just in one direction. I use the X and Y and Z component to have it move a little bit diagonally as well. And then I multiply that one by object to world matrix. And here's another thing that you probably need to wrap your head around a little bit when you do rotations. You need to multiply it by a matrix. So you probably have to Google that one and look at a little bit how that works. Maybe I'll do a video on that if there is enough requests on that one as well. And then I break it out into the component, the X and the Z component. I append those together, and then I have the wind direction, and then I rotate this value around the axis, the up axis. And finally, when I have that value, I feed that one into here, local vertex offset, and that offsets the vertex from where it originally was then. And I also forgot to mention that the color value here is coming from the albedo, is that how you say it, map. So those are the two things that the shader outputs, the albedo, and the local vertex offset. So those are the things. So yeah, that if you're new to shaders, this was probably just mumbo jumbo, but maybe it'll still give some insights to how these things are constructed. and hopefully I'll do some more videos on this. Maybe I'll make a shader from scratch, but usually it's for me it's a lot of trial and error, and I go scratch my head for a while and try to figure out why isn't it moving in the direction I want, and then I add another component and I append this value and I drag this one there, and I see in the scene why is it flipping upside down, then I have to think about that, and I Google a little bit and I get frustrated, and then I go back and then I pull another thing, and finally I get to this point where it works. So yeah, I think that will conclude this video, and hopefully give some insight both to the shader itself and bringing this low poly into Unity to see what it looks like. And yeah, I think that's it. Maybe I'll do a video about the waterfall as well. That's with a particle system that throws up meshes. So maybe I'll do one of those as well. So, right, thanks for watching. This probably turned out to be a lot longer of a video than I originally intended. So, but you can fast forward and skip it altogether if you want, or do whatever you want with it. So thanks a lot for watching, and stay in, I was going to say stay in touch. You don't need to stay in touch, but you can keep track of the progress of this game. This game is currently called That's Racing, and it's going to be a top-down or a isometric view racing game. So please do subscribe and follow the progress on that game. I think it's going to be a lot of fun. It's aimed to be a multiplayer game with some people running about that you can knock over and get into trouble for. So yeah, thanks a lot for watching, and take care, and see you later. Bye bye.